Okay, so this will be the next video in the series. It's still going to be a continuation of the device context. Okay, but in this video, we're going to look at how to basically copy and display a bitmap image in your window. Okay, but before we get into that, we have to cover some basics here. So when we call get device context, or when we call begin paint, the handle to device context that's going to be returned by the system to us basically is going to give us the access to the client area of the window. Okay, so that's where you will be able to draw if you call in get device context or get DC, or when you call begin paint. If you call get window DC or get window device context with the window handle, the Windows system is going to return to you access to the area of the window less the title bar. Okay, so that's going to be your drawing area. If you have a file menu, it's going to overwrite the file menu there. Okay, and then the next one, the final one, if you call window DC with the null handle for the window, you're going to gain access to the drawing area of the screen of the display there, basically. So of the desktop window. Okay, so that's what's going to get you there if you call get window DC. All right, so yeah, so that's just basics we have to cover first. Okay, so let's begin with how to get basically how to draw a bitmap image into your client area of your window. So the first thing we have to do, we need to retrieve a common device context with our window bitmap that will give us access to the client area of our window. Okay, so what will happen here? Think of it this way: when you call get DC or get device context with the handle to your window, okay, you're gonna get access to the bitmap that represents your window. Okay, so when you created your window, when you called in create function, create window function, system basically generated in its internal memory an image, a bitmap image of your window, if you want to think of it this way, and then give you a handle to it. So this was the handle here to your window, and then also give you a handle to the bitmap. So that's how they link here. You can think of it that way. Okay, so your window handle is linked to your bitmap image that represents your window. And then from the bitmap handle table, you get a handle to your bitmap and the actual address where the graphics information is being stored for your window this way. So when you call get DC, you get a device handle to a device context, which is handle to the structure, okay, with the bunch of default values here filled in for the graphics objects and graphics modes. Bunch of default values will be filled in, but the bitmap itself is going to have a handle to your graphics, to the window itself, where to the graphics where the window is stored, with the window the pixel data is stored. Okay, and then we have and let's say we want to display this H. We have here this H, so it is a second bitmap image that's also being stored in memory. Okay, so we have a handle here to it, and we have the address. So the way that you would load this image here, this H, you can think of it this way. Yeah, first you go basically create a drawing and save in the bitmap image. So what you do, let's say you go to paint, and let's say you draw this H here, right? And you save it as an image1.bitmap. Step 2, you basically add the bitmap file to your project. So if you have, let's say you have a project, you have your main CPP resource file, and then you add like image bitmap. So if you store it in the same directory as the other images, so you the system will be able to find it for you. So it's going to be a little bit easier to load into your code. So the way to add to your code, so on step 3, the way that you add this image to your code is as follows. You include resource.h file in your main CPP file. the resource.h file, you define an image like a variable. So you call define, and this can be IDB stands for ID bitmap, and then underscore, and then you can call it whatever you like. This is just convention; it's not a rule. Just by convention, you call ID, and then B for bitmap, C for cursor, and so on. So different letters have different meaning here. Image, and then you put like a value. Okay. So I put 800. It's a random value you can choose, but you can cross, I think, 20 some. It has to be below. It has to fit into 16-bit variable. So the value, so it has to be below 20,000, I think, something like that. So it cannot. The variable cannot be more like this. 800 cannot. It has to be stored within 16 bits. If it's anything above 16 bits, it's not going to work. Okay, and then you have the resource file. So in the resource file, you take this variable name that you define in the resource header file, and you include here. And you have to also include this resource h file into the resource rc file. So it has to include this resource h has to be included here, bitmap, and you call image1.bmp. Okay, so what we have to do here, let me just take 1 second here. Let me do this way here. Let me just move this lower here, like this. And let's do this here. Okay, do something like this. Just here. Include, and then you call okay, like this. Okay, so you have to include something like this. Okay, has to be this way. So they are linked together. Okay, so this CPP file is linked to the resource file via the resource H file. So that's how they link. So what will happen when you compile this, like so, you're going to get a program file / module, which is going to be the exe in our case. So you're going to have an execution section, execution code here. And at the end of it, you're going to be a resource section. So the system, when they compile, is going to include this image file. At the end of your, the bitmap is going to be included at the end of your program there. Okay, so that's going to be code first, and then the resources at the end. And here, very important that this image1.bmp has to be in the correct directory, so for the system to find it. Okay, the direct location of the image file. This is so since the image in my case is in the main directory of the project, then you just put the file name. Otherwise, you will have to include the directory name or names before the file name. So if it's in some, if you have to search for it, so you put backslash directory name backslash and then image name. Basically, you have to point to the where the image is located. Okay. Now, so the next step. So that's the step 3 here. So the step 4 would be to load the bitmap file into your code. The way that you load the bitmap file, it's very important that you don't load that file in a section of the code where it's continuously repeated. So for example, if you were to load it in a VM paint message, that will not be the best programming practice. So you load it where in a section of code with only executed once or not on a frequent basis. So for example, you can load it in a win-main function before like loop, while the main loop, program main loop. You can load it in a VM create message. You can load it in a VM command message. But loading it in a VM paint message might not be the option because the paint message is called continuously pretty much throughout the program, as long as the program runs. So you don't want to load it and unload it. That takes too much resources. So you just want to load it once and be done with it for the duration of the program. So here's what you do. To load bitmap, you call the LoadBitmap function. You specify the handle to the instance of the program. So the instance is basically the access. It's a handle where the is the value where the program is located in the memory. Okay, so it's a handle to the program basically. and then you call make into resource with the variable for the image that you want to load. So in our case, we want to load this IDB image one. So we load this, we specify IDB image one here, and we call them make into resource macro. The reason we call this make into resource macro is that the IDB image one, when we save here in the resource H file, we define it as a numeric value here. It was defined as 800, which is numeric value. The thing is, the LoadBitmap function here takes a handle to the instance, but takes the pointer to the string, which is basically a C string, okay, for the bitmap name. So the make into resource macro is important here in order to convert the IDB image from a number, which we define here, number, to a character string, since the function LoadBitmap signature takes a handle to the program instance and the character string to the program resource you are looking for to retrieve. Okay, so basically that's why you have to convert from a number, okay, to a character string. And that's what make into resource does for you. And that's how you, and then you're gonna get a handle, the load bitmap. If it's successfully loaded, it's gonna give you a handle to the bitmap. If it's not, it's gonna give you like the reasons why it failed. So you have to basically call an if function to check for the various reasons why it failed. And most of the time, the reason it's going to fail is because this will not point to the right location where the image file is stored. Okay, so if you have any problems, make sure you have the right directory here specified. Okay, or I should say the right path to the bitmap file. Okay, so that's how you load the bitmap. Okay, so let's go back here. So let's say we called the load bitmap. Okay, so we loaded our bitmap here. We have the handle of device context for the main window, for the client area of the main window that we want to display this, our bitmap in there. Okay, so the next step, and here's the very important here. The next step, we have to create what's called a compatible device context. The reason we have to create compatible device context is that the HDC that we retrieved here, okay, this handle to this device context, we retrieve the handle. This is the retrieve handle for the common device context. And the common device context will not, Windows, the system will not allow you to select an image, a bitmap, directly into it, because this bitmap here, basically in the common device context, represents the client area of the window. Okay, so you cannot change the client area of the window by selecting a different image for it. It doesn't work this way. Windows, basically the common device context is very restricted by Windows, what you can do with them. So once they are allocated, you can change other values in it, but will not allow you to change the bitmap in there. So the only way we can get our bitmap here, our drawing, into our client area is by copying it from one device context to the other. So we need to create a compatible device context so that we can select our bitmap into it, so that we can copy the bitmap into our window, since we cannot select our bitmap into the common device context. Windows would not let us do that. We can only select bitmaps into the memory device context. So to create a memory device context, we call create compatible DC, which stands for create compatible device context. And we give the handle to device context that we already to the common device context. Okay, so what this will do for us is here. So we have our common device context here, and the system is going to make a copy of this common device context, and it's going to create a compatible device context. So it's going to give us basically another copy. However, the other copy, the main difference here is going to be the bitmap. So what it's going to do, the compatible device context, the bitmap itself is going to be, the Windows is going to create a bitmap that is 1 pixel wide and 1 pixel high. So basically 1 pixel, okay, here. So it's going to create this pixel here for us. And as you know, bitmap with 1 pixel, we can do nothing with it. But by default, Windows will do that. We're going to create, when you create create compatible device, it's going to give you basically another device context, which is here handled to a compatible device context. And then it's going to basically, the bitmap is going to be one pixel. Okay, it's going to represent the bitmap, the handle to the bitmap. It's going to be 1 pixel. But the good news here is that we will be able to select a different bitmap and change this bitmap, like the compatible device context, which is also known as the memory device context. Windows will allow us to select a different bitmap image into it. Okay, and here is basically the two devices from my program here. As you can see, I made like the print out the values here. So here's the thing, everything is the same except for the bitmap. As you notice, the handle to the bitmap of one is different. There are different bitmaps here. And also, as you can notice, the region that's, I have still haven't covered the region in the device context. That's probably going to be in the next video, hopefully. But here you can notice that here's the represents our client area, width and height of our client, and here's width and height of the client area of the memory device context, which is the compatible device context. And both of them, see, there are differences. So this one is 1 by 1 pixel. This one is 684 by 491. Okay, so see the client areas are different. And in the graphics mode option here, as you can notice, they're both the same. So basically, so when you call create compatible DC, so basically you're getting the same, another copy of the common device context, except for the bitmap handles. So the bitmap handle in a common device context represents the client area of our window when you call get device context, while when you call create compatible device context, the bitmap represents just 1 pixel image. Okay, so here we are at this stage. So let's proceed further here. Okay, so we were here. Now let's go to this one here. Okay, so now we have our memory device context. In our case, it is called the compatible device context, so that we created using the create compatible DC function. Now that we have the compatible device context created already in memory, now we can select our image that you want, our bitmap image that you want to work with. Okay, so what we do, we call select object, then we specify the handle to the compatible device context that we created a few moments ago. And then we specify the handle to the image that you want to load. So in our case, when we do this, what will happen, this, let's say this 3457 handle represents the address of our actual bitmap image that you want. So when we call this function select object, what will happen, we're gonna basically put a new handle in the bitmap for the compatible device context, and the old handle is going to be saved, the old bitmap is going to be saved in the H handle to the bitmap. So basically we're going to basically link the compatible device context with our image. So now the compatible DC represents our, like, has access to the memory lock information, the pixel memory information for our bitmap image there. And then step 4, the next step, we're going to copy the image from memory device context into the common device context using BitBlt function. So the BitBlt function basically going to copy the pixel data from our image into the client area of our bitmap window. So we have the following setup here first. Okay, so this thing, the common device context here, okay, represents our window here, the window with the client area of the window here. Okay, and the compatible device context represents basically the bitmap in the compatible device context represents basically has access to the image data that we created. Okay. Now we're going to use those two device contexts and copy the information from basically from the compatible device context into the common device context. So the way it's going to look like this. We call BitBlt function. So it's BitBlt. We specify the common device context, handle to the common device context, which has basically a handle to our window bitmap here, to the bitmap that represents our client area of our window. Those two values here represents where you want to start the drawing in your client area of your window. So we have specified here that we want 1 pixel width, and so to the right, and 2 pixels down. Those next two values represent how many pixels do you want to write into. So the width and the height of the image that you're going to be copying. So like how wide and how high is the image that you're going to copy. So in our case, we specified 6 pixels wide and 6 pixel height. So we have 1, 2, 3, 4, 5, 6. So 6 by 6. So we're going to copy the whole image. You could specify 3 and 3, so it's going to copy the half of it. Or you can specify any number, okay? But this is basically, that's what it does here. Then the next item, we specify the handle to the compatible device context, which basically has a handle to the bitmap that we want to copy into our client area of our window, which links to the address where the bitmap color data is stored. Okay, so let's say this is address where the pixel data is stored. Okay, for that bitmap. Okay, so and then you specify 0, 0, 0. So in our case, we put 0, 0. So we want to start from the very beginning here, because you can copy, partially. You can copy from the middle or wherever you want. So you specify where you want to start copying. And SRC copy here, this is the raster copy operation. So what we do, we are telling the system here. So SRC copy stands for source copy. So we want to so we're telling the system basically to copy the pixel data directly as it is from the source into the destination. So the source pixel data will overwrite whatever is a pixel data in the destination there. Okay, so that's what we're doing here. So we specified here, so 1, 2, 6, 6. So we go 1 and then 2 down. Okay, and that's where we're going to start here. So 1 pixel and then 2 down, and it's going to start drawing from this location here. Okay, and then this is going to end up looking like this here. So BitBlt function, that's what it does for you. So that's how you get it. That's how you copy the image from one bitmap to the other. So you have to first load the data, the image data, into your program, and then you can retrieve the handle when you load it. You have the handle, and then you create compatible device context from your common device context. You create a compatible device context. Then you select an object. I mean, to select the image into the compatible device context, and then when you have selected into the compatible device context, you copy the information from your compatible device context into your common device context. Okay, so let's go to the next one here. Actually, no, this one there's nothing there. Okay, part 5. Okay, so here's how it works. So let me just go over the BitBlt function here and the raster operation in more detail. So here's how it goes. So as I said, the first is the handle to the common device context that you're going to be copying into. The first two values here is the starting location of the upper X and Y corner of the destination of the rectangle. The next two values is the width and height of the source and destination rectangle. Okay. And then the next item is here is the handle to the compatible device context. The 0, 0 here is the starting point of the source rectangle where to copy the data from. In our case, we start at 0, 0, but it could be anywhere within that rectangle. So you can start from 2, 2, 1, 2, 3, 4. So it depends where you want to start, but in case you want to copy the whole data. Okay. And then SRC source copy specifies the type of raster operation on how to combine the color values from the source bitmap with the destination bitmap. In our case, we are using SRC copy, which copies the source bitmap pixel color to the destination bitmap. Okay. Now, just to give you an example here, let's say we change it to another the same information, but we change it to an SRC source AND operation. Okay, and I also keep in mind I changed the background from a white to gray to give you a better idea what will happen. Okay, so what we do here is that, as you notice here, when you use SR source end, okay, we have the red, green, and blue values of the. So this is the background area. So this is the 128, 128, 128 for all. So it is the gray. This is the the binary representation here of the 128. This is representation, the binary representation of the 34, which is the green that we are using here, the 177 and 76. That's for the green that we have here. Okay, for red, green, and blue values. And the white is basically 255, 255, 255, which is basically white. Okay, so what we do here, okay, so when we do a raster SR source end operation, what will happen is the following. The background area is the gray, and the green here is this. Okay, so this is the green color that we originally had. So when you do AND operation on these items, so 1 and 0 is 0, 0, 0 is 0, 0 and 1 is 0. So all this will be 0. The next, so that's R. So here, so that's red. The next item is green. So we have gray area is 1, and then green 1. So we put 1. Everything else will be 0. Okay, because 1 and 0 is still 0. And this, and so so green is going to be 1, and then all zeros, and then blue is going to be all zeros. So what will happen then when we do copy this operation, you notice that it's going to be a little bit darker green, okay, for the color here inside. And when it comes to the white option, as you can notice, it's going to be replaced with the gray area, because the like 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 0, 0 and 1. It's going to repeat itself. So in the end, basically the white is going to be replaced with the background color. Okay, whatever it was stored there. Okay, based on this raster operation. So yeah, so that's the basics of basically putting a bitmap image into your program there. Okay, so we covered this item. So so here's what how it looks in code. So the first thing I use it in the VM paint message. Okay, so you go begin paint. Specify. I haven't covered begin paint yet, so we'll cover that. That's when we're done with the device context. I'm probably going to cover the paint, because the begin paint does a couple things for you. Okay, so then you specify the handle to the window and the paint structure. You specify that here. Then once you have the device context, you create a compatible device context here. You select the object, okay, HMemDC to the memory device context, the image one, and then you could basically BitBlt the function, called the function here, and I put two options here: src copy, src end. There are other functions available that you can. The other raster operations available that you can use, but you have to look them up what they mean for you. Okay, I didn't cover all of them. And then we select alt object back into the memory device context, and then we delete the alt bitmap. And we have to also delete device context. The memory device context has to be deleted also when you're done with it. Okay. And then let's see. Let me go here, back up here for a second. Let me cover the stuff here. It's not covered here. Where did it go? And okay, and here's the load bitmap operation. So I'm loading this in the VM create message. Okay, so you call the load bitmap here, h instance, make into resource idb image one. Okay, and you test it for if it failed load or not. Okay, and what happens when you execute the code? It looks like this. So this is the first BitBlt. Okay, that's using src copy, source copy, and this option is as source end option. Okay, so this, as you can notice, the color is a little bit darker, as I explained previously, and then the background also is replaced from from white here to the background color of the client area. Okay, yeah, so it's gonna be that's it for this video, and okay, thanks for watching.